starting with this first question, this is something that you do need to be able to do by hand. Okay? There is no way to expand into a different form for Desmos. On this, what you need to do is just be able to rewrite this in the expanded general form. And the way that you would do that is to expand the binomial square. So leave the 6 out front. X plus 4 squared, you square the first term. You take the product of the two terms and double it. So x times a positive 4 is 4x. Double that, you get 8x. Square the last term. Positive 4 squared is plus 16. And then the negative 6 still carries along on the outside. Distribute your 6 now. Get rid of our grouping symbols completely. So we get 6x squared. 6 times 8 is 48x. 6 times 16, if you're mentally calculating that, just do it in parts. 6 times 10 is 60. 6 times 6 is 36. 60 plus 36 is 96. Carry along that negative 6 on the outside, and the only thing you have left to do here is to group your only set of like terms. So you get 6x squared plus 48x, and then 96 minus 6 leaves plus 90, and that would be your answer. Okay. All right. The next one is one that, again, you have the answer. You almost have the answer. You have a portion of the answer just by looking at this general form. You know that the leading coefficient of negative 2 is also going to be the leading coefficient of your vertex form. Remember, vertex form is a times x minus h squared plus k. And so all we need to know to answer this is we need to know what our h and our k values are. If we know the h and the k, we plug them right into that form and we have our answer. Well, if we type our equation directly into Desmos, so negative 2x squared plus 20x minus 53. Okay, what we can do is we can simply click on the vertex of that. We know our hk is 5, negative 3. And we plug that in, 5 for my h, negative 3 for my k, and we have the answer. Okay? So you can use Desmos to identify that vertex like that. Okay? Which we can do in the next problem as well, right? So if we want to find just the vertex, we can type this equation, 9x squared minus 3x minus 1 directly in. Now notice these all these points, Desmos shows you x-intercepts, y-intercepts, and any critical points. So here this y-intercept of 0, negative 1 looks like it's pretty close to the vertex. Okay, but be careful. Make sure you find exactly where that is. And even if you enter your answer as a decimal, that's fine. If we just copy that down. Copy to at least 4 decimals, I would say. And so this is an acceptable answer. It's not ideal. Ideally, you have the rational form. Ideally, you're using the negative b over 2a to solve this. However, Desmos allows you to find that nice and quickly in that regard. Okay. All right, the one thing to do to make sure in both the instances of what I use Desmos for, the problems have been in terms of x. Desmos only understands x's and y's, so make sure if you have variables other than x that you convert it into that when you write your answer. All right. Next, we have the question where it's asking you a number of parts for the equation. Once again, if you just type it directly into Desmos and then look at the graph, you'll get every piece of information you need from that graph. We have our vertex, we have our y-intercepts, we have our x-intercepts from here. And so when you are plotting a graph, okay, so the first thing is to graph this. The first point is going to be the vertex. So we see on our graph here that the vertex is negative 1, 1. So negative 1, 1 would be the first point I plot. And then the second point can be any other point. It turns out that both the x and y-intercepts are shown on this, but if you have a y-intercept that's not shown, you might just need to plug in and evaluate a different point that you see. Here, though, we can see 0, 0 is a solution. Okay, that is the y-intercept. And once you have 2 points on this, the graph will autofill. It'll create its own. So the second point is one of the intercepts, if possible, okay, or another point that you would just evaluate. But usually you can find it as one of the intercepts. We can see here, again, that we have 0, 0, and negative 2, 0 as the x-intercepts. It doesn't matter which order I write them in. Just separate them by a comma, no spaces. The domain is something that you just need to be aware of. In a parabola, there is no limiting x, no input that doesn't work. So the domain is all real numbers, which you can express as negative infinity to infinity with parentheses at each end of that interval notation. The range is the possible y values. There is, again, for the domain, it goes from left to right, least to greatest. For the range, it goes from bottom to top, least to greatest. So if we look, what's the lowest possible number that our graph represents here? Well, that graph extends all the way down to negative infinity. Always a parentheses at the infinities. Notice I do have that negative sign. That just means it's to the left of, or in this case, below the 0, the origin. And then the range extends all the way to the highest point. So the highest y value in this graph is right here, 1. And it is included in interval notation. If a point is included, it's going to be a square bracket. And so make sure you end your interval notation with that.
Wait, so is that because it's positive? Because when it's negative, is it the negative wires at the front, and then it's just regular infinity, and then
Yeah, if it opened up, then the infinity would be second, regular infinity, positive. Okay, and then finally, the equation of the axis of symmetry, that's just a vertical line that passes through the vertex. So it's always going to be the x equals and whatever the x coordinate of your vertex is. So in this case, a negative 1. All right, and so those would be your answers for that problem. Okay, but it's all observable by looking at the graph. All right. Next, finding the equation of a line, okay, or a parabola. We talked through this, how to do it by hand. It's not a difficult process. However, if you understand how Desmos works, Desmos can make it even easier. Okay? And that is, you can use what's called regression equations on Desmos. To use regression, you need one more point than the power or degree of the function. So a linear equation has a power of 1, right? X to the first. So you need 2 points to plot or to use linear regression. For quadratic regression, quadratic function has a power of 2, a degree of 2. So you need one more than that, 3 points. Well, we have 1 point given, negative 6, negative 5. We have a second point that we can easily find, which is the vertex, negative 4, 1. And then the easiest way to find a third point is because a parabola is symmetric across that vertical line of symmetry, if you just look straight across from the given point, you should find that there's another intersection on the same y, and just locate what that corresponding x would be. And so once you get 3 points, you can just plug it into a table. This is the same Desmos that appears on your standardized tests, like the SAT. You'll have this option. You hit plus, add item, and choose table. And then just put these 3 points in. Negative 4, 1 is 1 point. Negative 6, negative 5 is a second. And then negative 2, negative 5 is a third. Now you can kind of see these points are plotted here. But if we want to turn it into an equation, we click on this button that says add regression. This is something that has just shown up over the last few months or half a year. Okay, so if you click this, it creates an option for you to choose what type of regression we're running. This is not a straight line. This is a parabola or quadratic regression. So we choose that, and it gives us our equation right here. So one possible answer for this, if you wanted to write your answer in general form, is negative 1.5. X squared minus 12x minus 23. So that is an acceptable form. However, what if this question was asking you to specifically enter your answer as vertex form? You can still use this quadratic regression because the a value is the same for all forms of a quadratic function. So if I wanted to write this in the vertex form, I would still have my a value of negative 1.5, x minus my h value of negative 4 squared, plus my k value of 1. And so this would be a secondary equation that would also work. So in that, if they give you a specific form that they want, you can just use the regression to find this, the a value here. Okay, now, you don't need to know this, but I'm going to talk through it anyway. Before that little button appeared last year, or between last year and this year, you used to just have to know how to pull up regressions. And the way that you pull up regressions is looking here at our table. Notice this isn't just x and y, it's x1 and y1. So what you can do is you can pull up a regression for y1 by just typing y1 is similar to. Now, if you don't have your keyboard with you, you can always find the similar to in the embedded keyboard. Just click on the alphabet keys, the letters, and if you scroll across the bottom, here's the option for that similar button. And then you can type in any form that you want. So if I wanted the vertex form, I could type it as x times, again, we have to use x1 instead of, or the x1 instead of x's, but I could type in a times the quantity x1 minus h squared plus k. And notice what this does is it gives me my a value, my h value, my k value. And so that allows you to find those. Now, here's where this could potentially be, again, helpful, is if you were asked or if you had to form an actual rational expression, negative 1.5, it's pretty clear that that's negative 3/2. But if you needed to see it, if it was something else, you could always go into a separate line now, type A. A represents the negative 1.5, and if you click the button that turns it into its rational form, you would see the negative 3/2. So if you needed to find the rational form of one of those, you could always pull it up in that particular case. All right, so that is one unique way that you should hopefully be more familiar now to use Desmos, the regressions. We'll come back and look at some like where we can use that for lines as well. All right, the next problem is solving an equation with one variable. Again, this is something that you can do by hand. Anytime on the SAT, especially, that you're being asked to solve for something and it's not the variable itself, it's an expression that contains the variable, like this one, 4t. Usually what you can do is you can just manipulate the given equation to leave 4t on one side of the equation, and there'll be a number on the other side, and that's your solution. However, if you are going to use Desmos for this, you can just solve for the variable. So what we want to do using Desmos is find what t is, and then we can substitute that in as 4 times whatever that is, and that's going to be our solution. So Desmos can only work in x's and y's, so let's change all of these to x's, all the t's to x's. And if we write each side of the equation on a separate line, so here if we write 3 times 2x minus 5, all plus x, so there's my left side of the equation. And then I write my right side on a separate line, 6 plus 3x. Again, I've turned everything into x's. If I then look at that system and see where they intersect, the intersection is my x value. So the 5.25 is what my variable, in this case t, right, is equal to. And so that's not my solution. That's not what I'm solving for. I'm taking that times 4. And so that's my answer. If I wanted to get the full answer, 4 times 5.25, I see that it's 21. So once again, I could enter a calculation or the calculated value from those. All right. The next question is just one that you really just need to look at it and understand what function notation represents. So this is a graph of f of x, and if you're asked to evaluate f of minus 2, it's telling you when x is negative 2, so right here, what is the whole value? What's the output value of that? And so if we look down, we see this is the point, negative 2, negative 3, so the output is that answer, negative 3 in this case. So that one you just need to be able to do by hand. Again, there's about 4 or 5 that are ones that you just need to know how to do by hand. All right, these next few are ones that, again, you should be able to do these by hand. The idea is by now, and we just went through this a few times, but you should be able to reverse FOIL and factor all of these, right? When you reverse FOIL, you're looking to see what are the 2 factors of your last term, negative 10, whose sum is the middle term, plus 9. Okay, and so that should be something that's probably faster to do by hand than it is to do on the calculator. However, you can do this on the calculator by thinking in terms of intercept form. Okay, if you think in terms of intercept form, okay, we can use the Desmos. If we just type this directly in, notice again I've turned my r's into x's. And if I then find my p and my q, right, my p and my q represent the intercepts. And so what I have is, I have my a value is 1. I have my p value I see is negative 10, so x minus a negative 10. And my q value is this 1, the second intercept, so minus 1. And so this is my answer. Notice that one's in terms of x's, right? You'd have to convert it into the right variable. Okay, but those are the same thing. So you can still use Desmos for that. All right, so let's see how that would work in this next example. Once again, I think the next example is easier to do by hand. Okay, however, if we're doing this by hand, we have the difference of 2 squares, right? We have the base 1 squared minus the base 5x squared. So if you recognize the difference of squares has a factor pattern of the sum and difference of the terms being squared. So 1 and 5x, the sum and the difference. This is, again, the ideal answer, the ideal way that you would enter your answer here. And you're using the factoring pattern. But what if you wanted to do this with Desmos? If we think of it in that intercept form, what's our a value here? Negative 25. And so if we just type that directly in, 1 minus 25, turn it into, or it is already x squared. Okay, so here's our graph. If we look, we have our 2 x-intercepts. We have a minus 0.2, so x minus a minus 0.2, and we have a x minus 0.2. So this would be the acceptable secondary answer. Okay, now, this is where that's a confusing answer to you, right? We don't really work with factors and decimals and fractions. Okay, and so what you would likely want to do, if you're going to trust Desmos to answer this, make sure you remember your a. The a is the same no matter what form. And then what I would do is I would just go into Desmos and I would write this set of factors. Minus 25 times the quantity x plus 0.2 times x minus 0.2. And I would just double check and see, is this the same graph? So if I toggle that on and off, are those the exact same graphs? Yeah. So it passes that check on there, so I know either one of those is acceptable. All right? So if I do that same thing here, okay, again, this is one that you can either reverse FOIL or you can rewrite the middle term and factor by grouping, or you can let Desmos do it. Type exactly what you have. Again, change the variable into x's. So 10x squared minus 7x minus 6. You find your intercepts, negative 0.5 and 1.2. And what we can do here is, we can find our a value is 10. Oops, I need to change those to z's. and then find our two intercepts. So minus a 0.5, so minus and minus becomes plus 0.5. Z minus a 1.2 becomes our second. And so this is our answer. If I wanted to verify, is that correct? I'm just going to type that in 10 times, remember, use x's, plus 0.5 and x minus 1.2. Are these the same graphs? Yeah, I toggle on and off. It's the exact same thing. And so I can confirm that yes, in fact, that is a correct answer. Now, ideally, if you are factoring this, the actual factors are going to be the following. 5z minus 6 and 2z plus 1. Okay, so those wind up being the exact same factors, or the exact same graphs, but they're just slightly different forms. The next question, systems of equations are super easy to use Desmos for because you just type each equation in a separate line. Again, make sure you use x's and y's when you're doing that. And if you find where they intersect, you get your answer. The x is -3, the y is also -3, and that's your solution. All right, the next couple questions here are ones that you just need to be able to answer by hand. Calculating slopes is just counting rise over run. So here, if you find any 2 points and then count it up to over 1, and that gives you your slope of 2 over 1, which is 2. For the vertical and horizontal lines, I always think of it in terms of, like, can you drive on that slope? Can you drive up a hill that's just straight up and down? No, not possible. Okay, so this is undefined. Remember, on here we use DNE for undefined. Can you drive on a flat line? Yes, that means it's a slope of 0. It does exist, okay, and so the slope itself is 0. Those ones you just need to be familiar with them. Okay. All right. The next one, again, sort of a combination of that. Okay, easiest way to answer this question is also by hand, because especially they have a specific form in mind. They want point slope form. Point slope form is y minus y1 equals m times x minus x1. This is just the equation of a slope, how to calculate slope, where it's cross-multiplied and written with no fractions. Okay, and so what you know, even just going into this, you have a given y and an x, so you have these two numbers. So if you plug in y minus 5, the y value, is equal to, our m is what we need to solve for, times x minus our given x, 7. All we need to know is what's the slope of this line, and the easiest way to find it is just to refer to the image, count, and find 2 points, count our slope. Here we go down 1, 2, 3, and here we go over a total 1, 2, 3, 4, 5. We go over 7. And so our slope is a -3 over 7. And that's all you have to put into this in order to get your answer. Okay. Using the Desmos for this, you could plot these 2 points right here and here, and then use linear regression to find the slope-intercept form. That does give you the slope, but it's easier just to count it. Okay, same on this next one. The easiest thing to do on this is just to rewrite this in slope-intercept form. So that's solve it for y. So if you leave the 2y where it is, subtract 8x, and leave the 9 where it is. and then isolate your y by dividing every term by 2. This is going to give you the slope of your given line. And so if you want the perpendicular, if we know that the slope is equal to -4, the slope of the perpendicular is going to be the opposite sign and the inverse, or the multiplicative inverse here. So +1/4 would be your overall slope. So that again is just something that you should know how to do by hand. Okay, the next question again is one that you should probably do by hand. We're calculating slope. So we've already seen this. This is just the difference of y's over the difference of x's. So if we choose any two of these points, and it can be any two, okay, and we take the first y, n plus 79, minus the second y, n, and divide by the corresponding x's, -2 minus 0. If we just plug those right into the calculation, n minus n, that cancels, leaving 79, -2 minus 0, -2, and we get our solution, the drop down, or from the answer choices. All right, next question is one where, once again, you can do this by hand or by Desmos. I'm going to show you by hand first because it is really easier to do it by hand. It's this same calculation, right? The slope is the difference of y's, so -9 minus 3 over the difference of the corresponding x's, 7 minus a -12. So if you just entered this calculation directly in, you're good. Okay? You can enter a calculation. If you don't, you can add them together. 7 and 12 is 19. So this is your answer. It was a pretty easy pretty easy calculation by hand. If we're going to use Desmos for this, what we can do is go in and use regression. If we add an item and choose table, we have 2 points. We have 7, -9, and we have -12 and 3. If we use linear regression here, we only need one more point than the power or degree of the function. Linear functions are first degree. So we have 2. If we just click linear regression right here, we get our answer, and that is the solution, -0.631579. That is equivalent to -12/19. If you have any doubts about that, -12/19, we can confirm that those are the exact same answers. Okay? So you could have put the decimal form there using Desmos as well. All right, the final problem is one that, again, it's just easiest to answer it by hand. It's converting radians to degrees. There's a conversion factor that exists that for every 180 degrees, it's equivalent to pi radians. Okay? And it doesn't matter. These are just conversion factors. It doesn't matter which one goes on top. Okay? They're both considered the equivalent to 1, right? It's the same thing. And so if you just take what's given, 7/6 pi, and use the units, these are in radians, the conversion factor that we need to use needs to cancel radians. So pi radians in the denominator, 180 degrees in the numerator, is that conversion. This allows us to cancel the units, cancel the pi. 6 goes into 180 30 times. 30 times 7 is 210. And so that would be your answer for that last question.